One of the things that is counterintuitive to a lot of people about number systems, specifically the number line, is such that we don't even realize that the number line is just a straight line. And not all lines are straight, whereas some lines are curved. And what that means when we say that the number line is a straight line, we're denoting that at no point towards negative infinity or positive infinity that this line has any curvature to it. That's one of the interesting things about straight lines and how they differ from curved lines. Now, interestingly enough, when we write numbers, they are symbols with no clear connotation, such as if I were to write the number 442. It has no connection to anything. It's a separate concept. But if I were to write a 1 here, that denotes some space that does exist on that straight line, and therefore we have the beginning of a numerical system. And what's so interesting about number symbols is that this one not only names or is a nominal number in reference to a space on a line, which we call a point, and lines are made of points, is that this symbol also refers to the concept in our mind. And that's an interesting thought, in that some symbol on a piece of paper can have nominal capabilities about a space as well as a concept that includes the idea of the space here, but it's totally different and separate. And so one of the reasons this is because of Zeno's paradox. In our minds, we can imagine an infinitely divisible space. But in reality, we can only divide a space so many times, such that, let's say we were going to use decimals. We could put an infinite number of combinations beyond the decimal point. But if we were to actually measure this, we would find out that there's a limit to how many marks we can put in there for a measure. And they won't be infinite. And this goes all the way down to the Planck scale, which is the smallest unit of measure, if I remember. And so you can also think of sub-scale to the Planck scale, such that there could be smaller numbers or smaller spaces. But we usually don't think about this as being a straight line separate from the number symbols themselves. And that's really interesting when you think about it. And so, interestingly enough, I was thinking about the number line, and I realized something. All numbers not only denote a coordinate space on a line by naming the x value, such that we would normally write, like on Cartesian coordinates, x, y, in parentheses. Coordinate like this is just x. So when we think about numbers, they're also vectors because they have direction and magnitude. That's something else they name, such that the magnitude is the 1 or the 2, but it's also the length, such that we can think of it like that's a vector of 2. And then if we had like a 0, this would be a vector of 1. And interestingly enough, you can transfer these vectors to kind of look like this when you graph them, such that would be each time you go up by another 1, a value of 1 on the vector. And they all have direction and they all have magnitude.